It's my great pleasure to introduce Bob Muglia. I've known Bob now for almost 20 years. It's hard to believe. Bob has had an incredible career, many years at Microsoft. He is responsible fundamentally for building SQL Server and all the things that sort of go around that and the data aspects of that.
Bob, a lot of people are responsible for that, but that's okay.
but I think you led it quite nicely. And I think, at one point, Bob was one of the four presidents of Microsoft before leaving. And then subsequent to that, he joined Juniper. And then most recently, he was the CEO of Snowflake up until just a few months before IPO. So Bob knows how to build big things, big successful things, and he knows a lot about data. Right, that's sort of been the story arc in Bob's career. I've been very fortunate to know him. I've been very fortunate to get his guidance. In addition to being very accomplished, he's an incredibly kind human being who is tremendously intellectually honest. And it's just been a pleasure to get to know him. And I hope through this discussion, you guys get not only a flavor of Bob's intellect, but also his ability to be communicative about all the things that he thinks are really important going forward. Bob, is that a reasonable introduction?
Well, it was much too illustrious, but other than that, it was fine. I mean, I appreciate all the kind words. It's very nice of you. It's good. It's been good to know you all these years, so and work with you.
Thank you very much. So let's get started. The first question, Bob, is that you've been involved with setting the agenda for data for your entire career, not only at Microsoft, but at Snowflake. Can you share with us the challenges you faced first doing SQL Server at Microsoft, and then compare and contrast those challenges with the challenges in building Snowflake? And I mean this question to address both building the software and customer acceptance and readiness for the solution.
Well, you're dealing with a lot of time frame here, right?
Yep.
Because I first started working on SQL Server in 1988. And that was the early days of standardized database adoption. It was pre the days of standardized applications, right? SAP was long in the future at that point in time still. And while Oracle existed, it was a database company. I mean, Oracle was very successful by 88. But there was a days when building transactional systems, fundamentally building operational systems, was very, very difficult. These new SQL-based databases made that much easier because of the flexibility that SQL provided, the ability to do reporting effectively, which previous databases, the more networking style databases, reporting was really, really difficult to do. This is before the idea of analytics, really, we called it reporting back then. These databases made things a lot easier. The other big transition that was happening at the time was this is a period where computing was still done on mainframes or mini computers, and it was really the beginning of the advent of the x86, the industry standard computing. And in some senses, most of my career at Microsoft was spent enabling the adoption of industry standard computing to a very broad audience of business customers. And I feel like Microsoft played a very major role in that through the 1990s and into the 2000s and in the 2000s, where, these are the days, you have to remember, these are the days where most companies were not automated. Certainly no small business basically was. And even most, large companies were still running on pen and pencil in a lot of ways. And, they had some business systems they were doing on these mainframes and things, but they were very, very limited in what they would do with it from reflective of what their business was all about. And it was the adoption of industry standard computing that enabled a very broad number of customers to adopt the technology. And in my experience at Microsoft, initially building SQL Server, but then as I ran other parts of the server organization throughout my career, putting all of the pieces together, we used to call it back office. There was a product bundle for that, but more importantly, we put together, and the product I'm actually quite proud of is Small Business Server, which automated literally millions of businesses. I mean, it literally made it brought computing to just gigantic numbers of companies around the world. And, you know, in some senses, what we tried to do with Snowflake was in a way similar on the analytics side of things predominantly, in the era of the cloud, you know, 20 years later or whatever it is, 30 plus years later. And really that was taking and adopting the attributes that are possible now with the cloud, you know, the elimination of impedance to adoption in so many ways, you know, whether it's installing the software and getting it properly configured, buying the software, maintaining the software. I mean, all of those things are totally different in a cloud-based world, and enables just much broader adoption at a faster pace. But the thing that's interesting in all of these cases is it's the fundamental of what the database, you know, of all of these pieces to this, you know, at least I've run the Systems Center at Microsoft, and you know, other you know, parts of the, certainly Windows Server was, you know, the operating system was very core in our world back then. But, you know, to me, the database has always been the heart of the business application. And in today's world, that is shifting more from operational systems to analytic systems, where a lot of the more interesting things are happening in today's world. And you know, that's where sort of Snowflake came in that, you know, with Snowflake, what we were able to do is really break through the limitations that existed in previous systems by adopting the architecture of the cloud. I always said what made Snowflake different from everything else that came before it was architecture, and the fact that it leveraged compute on demand, and it leveraged blob storage, immutable blob storage, and you could have essentially databases of any size and an infinite number of effectively infinite number of users working against it simultaneously. You know, those breaking through those limitations really changed the playing field in terms of what's possible in terms of business applications, and in particular these analytic applications that are now becoming much more important to what people are doing in business. But in some senses, the trajectory is really the same, right? It's taking a problem that was hard for people to solve without this new advance in infrastructure, and really through some transformational things. In the case of what I did at Microsoft with SQL Server, it was really the adoption of industry standard architecture. And in the case of Snowflake, it's the adoption of cloud architecture. So in some ways, it's the same trick. In some ways, it's the same trick.
So here's the question.
Two very different time periods.
Right, but here's the question, right? So you said you were very proud of the small business solution that you came up with, and it really enabled a whole lot of people to take advantage of sort of the core assets that you were building. Is there an equivalent to that for Snowflake?
Well, I mean, it's interesting. I mean, first of all, in some ways, you know, the cloud is an operational, you know, is a system that allows, you know, people to build applications of any type. And in some ways, there's some similarity to, in odd ways, to Small Business Server, in that we put everything people needed in one box. That was the whole idea of Small Business Server. That you could buy one server from Dell or wherever, and you know, for a few $1,000s, you had a complete solution that could run that plus an application could run a small business. I mean, AWS in some senses is that today, and it has certainly replaced that. You know, AWS, Google, Microsoft Azure, those have really replaced that. Now, Snowflake's trying to do something pretty different right now in that you know, they really have effectively three businesses that they're fundamentally building. One has been the traditional database data warehouse business, which is what I spent most of my time doing when I was there. You know, the second one is the data sharing, data marketplace business, which, you know, was very much started during my period and is, you know, when I was there, and it's now it's now living out the vision of that, you know, with being a marketplace and really beginning to see a robust ecosystem being built on that. And the third thing they're doing now, which I think is quite creative and is clearly post my period at Snowflake, is this creation of a cloud, the data cloud, as an overlay cloud in some senses on top of you know, all the other clouds. And you know, you saw this in the recent summit, and they're very much, you know, encouraging people to build applications on top of that. So yes, they are doing this. They are very much doing it, and it's, you know, they're I think it's important for them. I think they're very focused on it.
So look, as these cloud offerings get more mature, What are your thoughts about cloud native versus on-premise versus hybrid? And in particular, where do you think enterprise will wind up?
Well, I'm a big cloud believer. Let me first start by saying, which is I think most companies go to the cloud all in, totally, no exceptions. I'll start by saying that. Most companies, I would certainly say that's true. And if you look at the majority of companies, the largest companies, and in particular, the more highly regulated companies have a lot of, things that they're concerned about, that are viable concerns they have. They have historically solved a lot of those problems, issues of data sovereignty, security issues, things like that, through on-premises installations. And I'm sure that many will continue to do that, at least for some part of their business. I believe analytics needs to move to the cloud, period. I mean, I'll just say that, where you can say your operational systems run, people have been running them on premises, they can continue to do that, and some will continue to do that effectively. It's very difficult, and it only makes sense for the absolute largest of organizations to have their own computers, their own data centers for doing analytics and analytics applications because of the elastic nature of the business problems, right? The cloud lets you take advantage of the fact that some of these problems require you to put hundreds or thousands of servers on a given business problem for a limited period of time. And you can do that economically on the cloud and have those resources come and go. Whereas if you have to purchase them and amortize them, you have much more difficult financial models that you have to run. And, that makes sense for, certainly makes sense for the biggest tech companies. It may make sense for some of the largest, financial services. And of course, there's the federal government, which is its own world. But for most companies, I think analytics will be done on the cloud. That says the world moves, at a gradual pace, and we're still in the cloud transition right now. We're still very much in the middle of it, and companies will be many companies are still in the process of moving their analytics to the cloud, and that is, beyond email and a few other secondary applications. It is probably the biggest thing that they're moving.
So you draw a distinction between analytic systems and transaction systems. Do you see?
I call them operational systems.
Right, operational systems.
Because I think transactions are important in both places. I actually think transactions matter in both places.
So do you see people like Snowflake and Databricks and others actually embracing the operational systems as well and trying to provide?
Well, Snowflake's starting to do that, right? I mean, they just announced some things. They're starting to do that, and we'll see what level. They want to build it. They appear to be building a much more complete platform. And in order to do that, you need an operational cloud database, that can handle a large number of transactions per second. And Snowflake was never built to do that. The original Snowflake was built to be analytic data warehouse, and they're now expanding their service offerings to do more. Right. I would not be surprised to see Databricks following. My view on this in general is there are five. The modern data stack, which is sort of the central idea behind this, today's modern cloud analytics world, is this idea that there's a number of different vendors that work together to build a very cohesive solution. And the attributes of being in the modern data stack, are that it's a cloud. It is offered as a service. It is something that you can scale and take advantage of anything that of the full resources of the cloud. And the third thing is that it uses SQL really as the core way you model data. And we've now seen a wide variety of vendors cooperating together to build these cohesive solutions for customers, that are often termed the modern data stack. There are five, core platforms to that. Snowflake and Databricks, are both competing, with their lives. They're both competing head to head against each other. And, then the three cloud platforms, Amazon, Microsoft, and Google. And I see all of them building very similar products that have the concept of, an analytic cloud data warehouse, SQL-based data warehouse, together with a analytics platform, typically built around the data frame in Spark. Spark, but the data frame typically is the way it's built. And that's the core of the data platform. And now Snowflake is expanding what they're doing, to include other characteristics. They had the marketplace, the data marketplace, and data sharing, and now they're expanding that platform to include more broader set of applications.
So, Bob, people are always worried about data and this notion of data gravity. We've all been talking about it. In the context of the earlier question, what role does data gravity play in the choice and interoperability of a customer solution? Does a customer stitch together across these different providers? Do they become single provider based? What happens with their data? Where does it move? Can you just sort of shed some light on that?
I think the reality, I mean, first of all, I think it's different based on the size and complexity of the company. I mean, I think if it's a small or medium-sized company, many of those companies will choose a single cloud provider, and they'll have resources in a very small number of regions around the world based on where they do business. And then they'll be running the applications on that they have to administer, plus whatever SaaS applications they run. I think that's the sort of the typical view of the world for a small to medium-sized company. It's much more complicated. It's a much more complicated world for the enterprise, where you have a wider variety of different environments that you're dealing with. You have on-premises systems that are pre-existing. You potentially have a number of companies that you've acquired over time. So you often have data centers scattered hither, thither, and yon all around the world. Likewise, you may have multiple cloud providers, both because of the fact you've strategically chosen that to not have a lock-in on a single cloud provider, and potentially because you've acquired a company that was on a different cloud provider, and so you have to deal with that. The net is that I think gravity, that the weight, let me put it this way, I'm not going to say that gravity is going away, data gravity is going away, but I think the weight of data is getting less and less in some senses, in that the cost of transmitting it over the wire, while I have not seen it go down materially for a while, I know it has to go down over time. And even if you look at the current cost structures, which are rather exorbitantly high from the cloud vendors to do egress charges, they don't charge for ingress, but they do charge for egress. Even if you look at that, the typical fee is about $70 to transmit a terabyte. And, that's 4 or 5 months of storage. In some sense, you can measure the cost of movement in some senses in relative to the cost of storing it for a period of time. And, because most data, certainly sizable data, has time importance associated with it. Time is really helpful here, right? If you simply establish yourself in a new place, over a year or two period, all your interesting data is going to be in the new place, right? Without having moved in a single byte.
Yes,
so I think that this problem does, I guess the net of it is that while I won't say data gravity is going away, I will say the weight of data seems like it's lessening. And certainly it's easy to move it. It's not a matter of the difficulty of moving it.
Right.
It's just the cost associated.
So you would argue that if I look at it in terms of time it takes to move the data, as that time gets shorter, then I'm establishing a new place. I can suck that data over a period of time, and I've got sort of a new center.
Or you just start accumulating your new data, and you move your new data over there, and over 6 months, a year, all your interesting stuff is in the new place. Anyway,
exactly.
Right. I mean, because you've got archive stuff in the old place, and I'm not trying to dictate a strategy for how people are going to do data migration. My point is, I think people put too much weight onto this overall.
Got it. No pun intended.
So to speak.
People build stacks using open source. There's lots of open source activity there. In this view of the world, what role does open source play?
Well, I think open source plays a really key role for components of everything. I mean, I think components are, many things are open source, starting with Linux itself, right? And so, in any solution people are going to put together, there's going to be open source components attached to it. The importance of open source is predominantly associated with things that people are doing within their own organization and building applications that they run themselves. That's what I hear again and again. And if I'm running it in a data center I control, even if it's in my cloud VPC, there's validity and interesting for me to be in open source. Once you're acquiring something as a service from another organization, the real question is, can you trust that organization?
Right.
Can you trust that organization to be around? Can you trust that organization to secure your data? And the answer is that it depends obviously on the company's sensitivity in many things, but the big thing is that a mature SaaS company can do at least as good a job of managing the application and data that they run as even a well-run enterprise can. And this view that the on-premises world, the I do it myself world is more secure. I think last year those things all went away. When we saw the breaches that came through last year that predominantly affected on-premises systems, all the cloud stuff was not affected. The general view I always had was that when we built Snowflake, it was incredibly important. Security was job one, job two, job three. I mean, it was most important. And it was architected in, and the operational systems were built in. And it was always such an important characteristic. And I know it still is. It's the same security team that's still there, managing that thing. And those people lived and died to make sure customers were secure. And their systems were so much more sophisticated than anything except the most sophisticated enterprise customers. Yes, we learn things from Goldman Sachs and big companies like that. Yes, you do learn things from companies like that. But other than those incredibly sophisticated security conscious companies, I think that SaaS does a better job overall. And certainly if you look at companies like Amazon, Microsoft, or Google, I mean, those are the leaders really in security in the industry.
So changing topics a little bit, we talk about SQL and sort of the classic database architecture, and then you have this new thing called AI and machine learning. How do these two things come together? What do you think happens there?
Well, I think that there's a journey we're on. And I think that where we are today is we have these standardized platforms that are bringing together the SQL analytic data warehouse or database together with procedural-based systems that are used to build both data applications, and to do data analytics in general. And mostly that's written in languages like Python. And we see a tremendous amount of adoption of that today. And if you look at the systems that are being built by all 5 of these different platform vendors, they include this hybrid of both of those two technologies into it. And in fact, if you're building a modern data application, a data app is an app that's built on the modern data stack. It's built on the analytic database, so it leverages the characteristics of that. But it also knows when data is changing. It responds to changes in data and takes some form of action, some form of autonomous capability is done based on changes to data. And that's really what distinguishes data apps in some senses from people apps or traditional operational apps, which always are just responding to people, right? You're booking an airline ticket, you're sending an email, whatever you're doing, it's responding to a human-generated action. Data apps respond to actions based, they take action based on changes in state to data. And today, all of these things are being built with this combination of the SQL database together with typically Spark, but the data frame and code like Python or Scala or something like that. And those things are very hybrid technologies. My analogy is always kind of the Prius, or I sort of think of those two, where you've got the internal combustion engine and you've got the electric motor. And I do see a day where that business logic will move into the database and it will be managed by the database, and will move from building these predictive ML-based tools, these predictive data, these data applications, will move from writing those in procedural code to writing them as declarative statements, kind of rules, but they're really relational declarative statements. And what we've seen in the last 10 years is that there's a new set of research that is now coming into fruition and coming into production, which has created a whole new generation of fundamental relational algorithms, that move away from what everybody's been doing with SQL really for 40 years, and changing from a world where today we do a binary join between 2 different tables to a world where we can do an n-way join very efficiently, working against fundamental relational objects, relational tuples. And one way to think about that is to move from a world where we think of tables to a world where we're modeling business systems. Today we model data in SQL. Tomorrow we will model business systems using this next generation of algorithms that take the form of what it's called a relational knowledge graph. And those systems will be able to incorporate the business logic directly into the database. and the system will decide what logic to run based on what's changing in the data. And that to me that's a gigantic change, because it moves from a world where today we program systems implicitly. We put the code a little here, a little there, a little bit goes in SQL, a little bit goes in Java. Everything is, there is an understanding of the business, there is a model of the business, but it's very implicit. It's in people's heads, it's in Slack, it's in email, it's in that Java code or that Python code. It's all over the place. The business logic is all over the place. We'll move from a world where that modeling is fully implicit to a world where it is very explicit, and you're explicitly modeling, understanding what the business looks like. And that's what you start with, is what is your business and what is your business process and what change do you want to affect? And you relate that into a system that is modeled and declared. And I think it's been a long time. This has been promised for 40 years. If you go back to the 1970s.
Bob, this reminds me of when we used to do entity relationship diagrams and things of that sort.
Exactly.
Right.
Exactly.
So this is basically taking entity relationship diagrams.
It's really object relational diagrams that work best, because those are more effectively defined. They're more consistent with the model. But when you think about entity relationship diagrams, you're thinking in the right general direction.
Okay, excellent. Well, look, our time is getting short. Any last words, any guidance to people who are listening here about how they should think about moving forward? There are lots of different choices that people have. I think you were very articulate in articulating sort of where the cloud is good, where sort of hybrid might be good, et cetera. Any other sort of parting thoughts on how people should think about things?
Well, I mean, I think the primary thing right now is there's a tremendous opportunity for people to transition their company to be very data-driven by adopting the modern data stack. Everyone should be adopting the modern data stack and should be somewhere on that journey in doing that and figuring out how those pieces fit together. And in the process, thinking about how can you work with predictive analytics, because that's where a lot of the gold mines in the future are. And are there these and begin to understand what data apps would make sense in your area, in your business, because most modern apps going forward will have that component associated with it, a data app. The people apps don't go away. They still, and in fact, the data parts of it get put back in people apps like Salesforce and things like that.
Right.
But it is a whole new way it's a whole new opportunity for application development. And it's only made possible with modern analytic systems on the modern data stack. So everyone should be on that journey. I agree.
Well, so in to crack a bad joke at the end, it's to say everybody should get Bob's data drift.
Well, they shouldn't drift away. Don't drift away. Stay focused.
Stay focused, but you should get the drifting towards data is what I meant to say. Thank you again for the time. Really, really appreciate it. It was an honor to spend time with you, sir.
Good to see you.
Cheers.
Thanks.
Dave, I think we're done, yeah? Dave, are you there? Bob, that was great.